Welcome back, boys and girls. So we are continuing with the paper 0620/42 of IGCSE from May June series. Okay, and we discussed the questions till question 3, and now we are proceeding to solve the next question, that is question number 4, and I am directly jumping towards question number 4. Okay, if you missed all those questions, please go back and watch all those videos related to question 1, 2 and 3. So in this, without wasting any further time, I'm proceeding. This is about the fluorine and chlorine, which are halogens. Then he says that suggest the appearance of fluorine. So again, here is a hint for you. Take out your exam notes. If you already know, that's very well. If not, then take out your exam notes and write down the colors. Okay, the color of the fluorine, maybe you can write yellowish or pale yellow or just yellow. Okay, both or all these three are correct. You can write yellow, pale yellow. Okay, but please write only one. Try not to write multiples. Okay, just write one, like I'm going to write yellow or pale yellow or yellowish, all correct. Then you have to remember and write down in your exam notes the color of chlorine, which is green or greenish. Okay, then for bromine, brown or orange, and for iodine it is gray or solid. So that will help, and further in future or when you are solving any other past paper, examiner may ask you the color of any other halogen to try to memorize all. Then next part he says fluorine react with sulfur to form a compound which has 25.0% sulfur by mass. As you can notice that the compound is just made of fluorine and sulfur. So if sulfur is 25.20, so sulfur, the value is 25.2 ratio fluorine. What should be the mass? We can say 100 is the total percentage, and out of that 25.2 is sulfur. Then how much should be the sulfur fluorine? So we can say it's 74.8. okay, so we can write the mass or the percentage is 74.8. Now to convert this mass or the percentage into the moles, how? Just divide by their atomic masses. The atomic mass of sulfur is 32, whereas the atomic mass of fluorine is 19. Okay, so you can also go to the periodic table and check what is the atomic mass of fluorine if you want. Okay, then but please try not to guess the values. Okay, try to use proper values from the periodic table. Now divide it. I'm going to use my calculator. So 25.2 divided by 32, the answer I got is 0.78, sorry, 0.7875. And by dividing the next value, which is 74.8 divided by 19, and the answer I get is 3.9368. okay, now to convert these two values, these two molar values, into the simplified whole ratio, we are going to divide with the smaller one. As you can notice, 0.7875 is the simplest or smaller value. 0.7875, I'm going to divide with that. So dividing the 3.9368 by 0.7875, I got 4.9. The value I got here, I'm going to write over here. For fluorine, I got 4.99, that is approximately equals to 5. and you can notice the values are similar, so it will be cancelled in case of sulfur, and I got 1. So the empirical formula which we obtained from this procedure is SF5, but the demand is writing the molecular formula. For molecular formula we are going to apply the again a formula, what, n times empirical formula, n time empirical formula. We don't know the value of n. To get the value of n, just divide the molecular mass, which is 254 given over here, molecular mass divided by empirical formula mass. So empirical formula mass can be obtained from here. We have one sulfur atom, which is 32 is the atomic mass, plus we have 5 fluorine atoms and the atomic mass of fluorine is 19. So the empirical formula we got here is 32 plus 5 times 19, and the answer is 127. Okay, so dividing it by 127, so 254 divided by 127, the answer is 2. So as I said, how to find the molecular formula? Just multiply by n, which we got is 2, with the empirical formula, which is SF5. So the final formula we got 2 sulfur atoms and 10 fluorine atoms. So we are going to write over here S2F10. This should be the molecular formula. Okay, so please carefully listen and carefully learn how I did this question. Just write down their percentages, and you don't know about the fluorine, just subtract it out of the 100, then divide it by atomic masses to have moles, and convert the moles into simplified whole ratio by dividing the smaller value. Okay, and then get the empirical formula. From empirical formula, find out the empirical formula mass, and then divide the molecular mass by empirical formula mass to get the value of n, and then multiply that value of n with the empirical formula. Finally you got this formula as a molecular formula. Now proceeding structure. So nitrogen trichloride is a covalent compound. Complete the dot and cross diagram to show the electron arrangement in a molecule of NCl3. Show outer electrons only. So priorly I'm going to write here nitrogen has the atomic mass of 7, mean there are 7 electrons, so electronic structure should be 2 and 5. For chlorine we know its atomic mass is 17, so atomic number, then electrons are 17 as well, so the structure will be 287. We notice that how many electrons chlorine required? Only 1. How many electrons nitrogen required to have its valence shell complete is 3. So starting with the least required, which is chlorine, so chlorine is going to share its 1 electron. So 1 electron and 1 electron here. At the same time, as chlorine has 7 electrons, out of 7, 1 is shared. How many are still left? So we have to draw all those like this. Same is the case with these chlorine atoms as well. Okay, so you can notice that how many electrons I showed for each chlorine? 7. 1 is shared, 6 are not shared. Now depending upon the mutual sharing ability, nitrogen is going to share 1 each electron with each of the chlorine, so that will make what? The dot and cross structure complete. The bonding, the purpose of the bonding is complete. Nitrogen required 3 electrons to have its valence shell complete. So did nitrogen what? He did, and then it shares 1 of electron with each of the chlorine, mean total sharing of 3 electrons. But out of 5, still 2 electrons are there which are not bonded. Okay, so this should be the structure. Keep that in mind. Out dot cross plus the outer valence electron must be properly shown, and the purpose of the bonding is to have valence shell complete. If you don't show the remaining electrons, their octet still remains incomplete, means the purpose of bonding should not be fulfilled, and this is negative. Okay, proceeding. Next is the structure of lithium chloride, which is ionic compound, is clearly mentioned here. Then complete the dot and cross diagram to show the electron arrangement and charges of the ions in lithium chloride. For this again, lithium has atomic number of 3, mean it has 3 electrons, the structure is 2-1. So it can lose easily 1 electron. For this, I'm going to show its only first electronic shell in which it has 2 electrons. One is lost, so it will have a charge of 1 plus. Then chlorine, as we draw already, it has the structure of 2, 8, 7 of electrons. So all you can see 1 electron is extra. Last electronic shell is missing. Last electronic shell. So you have to draw the last electronic shell. In that, please write down electrons in a single way like this. 4. Now start pairing. 5, 6, 7. So 7 electrons are of its own. 1 is gained from the fluorine atom. So you have to draw like a cross. Okay? Here. You have to, and then as it gained 1 electron, so you have to draw 1 negative charge over here. So this will be the structure of lithium chloride. In next part, he says that explain in terms of attractive forces between the particles. Remember, in lithium chloride there are opposite charge ions. There are opposite charged ions, and the attraction between the opposite charge ions is very strong. Whereas nitrogen trichloride, a simple molecular structure, and we can say that it is made up of the molecules. It is made up of molecules, which is simple structure. So remember that the attraction forces between the molecules are weaker, whereas the attraction forces between opposite charge ions are stronger. So we are going to say that there are, or in other way we can write, due to giant ionic structure with strong forces of attraction between opposite charge ions, lithium chloride is solid, whereas due to simple molecular structure with weak forces of attraction between molecules, weak forces of attraction between molecules, nitrogen trifluoride is liquid. Understood? You may reduce the words, but the theme must remains the same. Okay? And try not to confuse. I'm writing, the handwriting is little bigger, so when you write it and using these lines, you may proceed, you may exceed to 1 or 2 more lines as a very big space is given, but try to use only the given space. Okay? But try to use only the given space. Why I write it the more? So to illustrate you, to convey you the proper answer. Now you can reduce the words. Okay? You can reduce the word. So the question 4 is completed over here, and we will continue with the next question